All right, here's an interesting problem. Doesn't look like we have a lot of information. We've got a box that slides down a 35-degree ramp with an acceleration of 1.32 meters per second, which is the same as meters per second squared. Determine the coefficient of friction between the box and the ramp. Now, the first thing we probably want to do is draw a picture of this. So, I've got a ramp, and it's probably too big. Got this ramp, and I've got a 35-degree angle down here, and we've got this box that's on it, and the box is sliding down the ramp. We know that A is equal to 1.32 meters per second squared, and we want to find mu, the coefficient of friction. Well, to calculate that, it's going to be force of friction over the force of normal. So, looking at this, probably my first step would be to draw a force diagram. So that's what I'm going to do. I don't have a mass for the box. That may not matter. Let's see what happens here. I've got force of weight working downward, and that's going to be equal to mass times 9.8 meters per second squared. I've got the normal force working off in this direction, which we don't know, and we've got friction off in that direction again, which we don't know. Since this is on a ramp, we're going to go ahead and rotate this. So rotated, it'll look something like this. I'm going to have my normal force pointed straight up, my frictional force pointed this way, and then force of weight off in this direction, which again is equal to, this is g, the acceleration due to gravity. So that's how I'm going to abbreviate it, mg. Again, this is at a 35-degree angle. I think I can do better than that. It's at a 35-degree angle. All right, so we've rotated. Next step is probably to break into components. So I'm going to go ahead and I'm going to break this into components. This is going to be f of g in the x direction. This is f of g in the y direction. Again, it doesn't look like we've got a lot of information, but we'll work with what we have. Since we don't have a lot of numbers, let's not really put numbers in here until a little bit later. Let's just work with our variables. We may be surprised. So at this point, what I would do is evaluate the motion. We know that in the x direction, this is the acceleration in the x direction, and in the y direction, my acceleration is equal to 0. So at this point, we can go ahead and take care of some of the forces. So let's take a look at this. Since we're going to need the normal force at some point, let's go ahead and do that. In the y direction, sum of the forces is going to be equal to 0. So that means that f of n plus, let's do this. So f of n plus fg in the y direction. But you know what? Since that's going to be negative, well, we'll just put it in there. Fg in the y direction is going to be equal to 0. So that means that f of n is equal to fgy, which is going to be mg, that would be cosine 35 degrees, because fgy, that's the adjacent, so that's going to be fgy is going to be equal to mg cosine 35, and fgx is equal to mg sine 35. Again, I just stuck in G for 9.8 rather than writing a number and the units along. I'm just using that. All right, we'll hold on to that. In the x direction, sum of the forces is going to be equal to MA. So that means, let me do this in a different color so I can discern this. That means that FGX plus F of F, which again is going to be negative, is going to be equal to MA. So let's do a couple of things here. We're going to substitute in for FGX. Let's put in an mg sine 35. So mg sine 35 degrees. And I'm just going to make this minus f of f is going to be equal to ma. I want to solve this for f of f because I'm going to need f of f over f of n to get my coefficient of friction. So that means, let's go over here, that means that negative f of f is going to be equal to ma minus mg sine 35 degrees. Distribute this negative over to the other side, in other words, divide both sides by -1, and we're going to get f of f is equal to mg sine 35, because this becomes a positive, so I'm just going to put it in front, minus ma, because that becomes a negative. I'm just going to subtract that. So what I'm going to do is I'm going to divide out the m from both of these. It's the same m, I can factor it out. So that's going to be equal to m times g sine 35 minus a. All right, it might not look like much. I've got an expression for f of n. I've got an expression for f of f. What I'm going to do is I'm going to go ahead and put that into, let me slide that up a bit. I'm going to put that into my equation for the coefficient of friction. We know that mu is equal to f of f over f of n. So I'm going to have f of f, which is m times g sine 35 minus a over m g cosine 35 degrees. I've got m on top, m on the bottom. Check it out. Look what happens. Basically, m cancels out. What I'm saying is that I don't really need the mass of this box. The mass of this box can be any mass I want. It doesn't matter what I make it, I'll still get the answer I need because mass doesn't matter. It drops out of the equation. So what we wind up with is g, which is 9.8 times sine 35 minus a, which is 1.32. It's from up here. 1.32. Again, this is meters per second squared. This is meters per second squared. Down below, I've got g, which is 9.8 times cosine 35. This is also meters per second squared. I'm going to wind up with meters per second squared over meters per second squared, and I get a unitless number, which is what I should get with coefficient of friction. Remember, coefficient of friction is unitless. I can't just divide out the 9.8s because this is 9.8, and this is kind of like if it were in parentheses. But I've got everything here. I can go ahead and, I got numbers. I can go ahead and calculate this. So let me grab a calculator. Slide that down a bit and slide that over a bit. Oh, I guess I'll do it over here. All right, so I hit this on, there we go. And let me go ahead and do 9.8 times sine 35 degrees, and we get 5.62 minus 1.32, hit enter, and I get 4.301, and so on. Now what I'm going to do is I'm going to take that answer and I'm going to divide that by, let me put this in parentheses, 9.8 times cosine 35. Let me close that up. All right. Hit enter. Whoops. What did I do? Dang it. I hit it twice. I think it's 0.53 because I accidentally hit twice. Dang it. Yeah, I'm going with it. It's equal to 0.536. So my coefficient of friction is 0.536. So all I've shown is that I don't need mass. So kind of what I'm saying is if you're working with something that doesn't give you a mass, odds are really good you don't need it. But I just proved it dropped out.